The turbocharger, or turbo as it's generally called, seems to have acquired a certain mystique, but in fact its principle of operation is a simple one. In practice, providing it's used and maintained properly, it's a perfectly reliable device. In the event of a malfunction, however, the diagnosis and repair of turbocharger faults is relatively straightforward, provided that the operating systems are clearly understood and your approach is methodical. In this training video program, we're going to look at the principles of turbocharging, the operation of the individual components, and the 3 different control systems currently in use. So let's look at the reasons for turbocharging an engine. The main objective is to greatly increase the performance of an engine without increasing its size. The benefits are that the desired increase in performance is achieved without increasing the weight of the engine. The manufacturer can use an existing and well-proven unit to extend the engine option range, and by using the smaller engine, the bonnet line can be kept lower, improving the aerodynamics, and hence the vehicle's performance and fuel economy. The principle of turbocharging is to use the high-speed waste exhaust gases to drive a turbine, which, through a common shaft, drives an impeller. The impeller forces air into the inlet manifold, where it mixes with the fuel. The mixture then passes via the inlet valves into the combustion chambers. Because the mixture has been compressed, a greater volume of air and fuel enters the cylinders, which increases the efficiency of each firing stroke, thereby increasing the power output of the engine. It must be borne in mind, though, that this increased efficiency can only be achieved when the engine is developing sufficient exhaust gases to drive the turbocharger quickly enough to compress the intake air. This is calculated by each manufacturer to suit the individual requirements and vehicle applications. The applications we're going to look at are for the 1980 to 1983 Audi 205T, the Audi Quattro, the 1984 Audi 205T, and the Audi AT turbo diesel. They all have similar basic components, but the control systems differ. The main parts of the system are the turbocharger itself, the wastegate, which limits the maximum boost pressure, the overboost safety switch, which, should the wastegate malfunction, switches off the fuel supply or limits the engine RPM, depending on the model. The ignition advance and retard system, which is controlled either by 2 delay valves or, on the later vehicles, by the electronic ignition control unit, the intercooler, which is used to improve the efficiency of the turbocharger by cooling the charged air, and on turbo diesel engines, a dump valve is used in place of the overboost safety switch to control overboosting should the wastegate fail to open. Another difference is that the wastegate is an integral part of the turbocharger on turbo diesel engines. Let us now take a closer look at each of the components. The turbocharger can be broken down into 3 areas. 1, the turbine wheel and housing. 2, the lubrication and bearing housing. 3, the impeller and compressor housing. All 3 are bolted together as one unit, and there are no repairs or adjustments. In detail, the turbo works like this. The engine exhaust gases are directed onto the turbine blades via the channels in the turbine housing, driving the turbine at high speed. The impeller is driven at the same speed through the common shaft. At idle and lower part throttle openings, the exhaust gas flow is not fast enough for the impeller to compress the intake air, and so the engine operates as a naturally aspirated engine. As the engine speed increases, so does the exhaust gas flow, and so the impeller is driven more quickly. At medium part throttle, approximately 3,000 RPM, turbocharging begins to take place when the inlet air is compressed and supplied to the cylinders at atmospheric pressure. At upper and full throttle openings, or engine speeds above 3,000 RPM, turbo boost builds up quickly and would continue to build up to pressure which could damage the engine. This is prevented by 2 controlling influences, the first of which is the wastegate, which we'll look at in the next section.